Here's a quick video on calculating solution concentrations in mass percent, molality, and mole fraction. So if we made a solution by dissolving 56.07 grams of methanol in 423 grams of carbon tetrachloride, the question is, how do we express the concentration of the solution by mass percent? Okay, so mass percent, well, here we go. Mass percent is grams of the solute per 100 grams of solution. Right? That's what we mean by mass percent. So if we have 56.07 grams of our methanol, then we're going to have the 56.07 grams of methanol plus the 423 grams of carbon tetrachloride, right? That's going to equal 56.07 grams of methanol, our solute, per 479.07 grams of total solution, right? Which is going to equal then 0, if you do the math, 0.11704 grams of methanol per gram of solution. But since we have to express it in terms of 100 grams of solution, this is where in percent, most people don't realize you're multiplying by 100 over 100 and not reducing. So that's going to equal then 11.704 grams of methanol per 100 grams of solution. And since we have all of our numbers are given to 4 significant figures, we would say that this is 11.70% methanol. So that's how we would express that in percent by mass. Okay? So we make it the same solution, and the question then is, how would we express the concentration of the solution in molality, right? So molality is moles of solute per 1 kilogram of the solvent, right? So it's different from molarity. It's different from molarity in that we have a defined amount of solvent. Where in molarity, we're talking about a total volume of solution, so we're talking about solvent plus solute. In molality, we have a defined amount of solvent, right? Molality is about the solvent. Okay, so we need to, if our solute is the methanol, then we need to find out how many moles of methanol we have. We have 56.07 grams of methanol, and it's given that since we know that 1 mole of methanol is 32.04 grams, since we're given the molecular weight, and so that's going to equal 1.750 moles of methanol. Okay? And so we have the 1.750 moles of methanol dissolved in 423.0 grams of carbon tetrachloride. We know that there are 1,000 grams in 1 kilogram. So that's going to equal 4.13712 moles of methanol per kilogram of carbon tetrachloride, right? That's given, or that's determined, and now our numbers were given again to 4 significant figures, right? So converting that to 4 significant figures would be 4.137 molal, right? Molality is lowercase m. So that's how we would calculate the concentration of that solution in molality. So now we're looking at the same solution, and the question is, how would we calculate the concentration in mole fraction? Right? Well, we just determined, right? Well, let's see, mole fraction of component X is equal to the number of moles of that component divided by the total number of moles of everything in the solution. So we can start off here the same way. We can figure out the number of moles of methanol, which we did in the last one, so 56.07 grams of methanol. Because we know the molecular weight, we know that 1 mole of methanol is 32.04 grams of methanol, and that will give us 1.750 moles of methanol. Okay? Then we need to find out the number of moles of carbon tetrachloride, because we need the total moles, so we need to know how many moles of carbon tetrachloride there are. So we have 423.0 grams of carbon tetrachloride. We know the molecular weight, so we know that 1 mole of carbon tetrachloride is 153.8 grams of carbon tetrachloride. And so when we do that, we get 2.750 moles of carbon tetrachloride. Okay? So now, to figure the mole fraction of methanol, we have to put all of that together. We have 1.750 moles of methanol divided by all the moles. So there's 1.750 moles of methanol plus 2.750 moles of carbon tetrachloride. So that's going to equal the 1.750 moles of methanol divided by 4.500 moles total. And so that equals then 0.38888, and that repeated since I had something that was related to 9. And so since we have 4 significant figures, we can say that the mole fraction of methanol is, to 4 significant figures, 0.3889. Now, it didn't express the preferred solute and mole fraction. You can express the mole fraction of the solvent as well. And so if we look at the mole fraction of carbon tetrachloride, right, we know the number of moles of carbon tetrachloride. There are 2.750 moles of carbon tetrachloride. And we just found out there were 4.500 moles total. And so we can find out then that that is 0.61111. Again, that's repeating. And so to 4 significant figures, the mole fraction of carbon tetrachloride is 0.6111. Now, since it's about total moles, there's another factor when you're doing mole fraction calculations. That is, if we look at the mole fraction of one component and the mole fraction of the other component, and add them together, right, the mole fractions should always sum to 1. So those are that's a quick lesson on calculating solution concentrations in mass percent, molality, and mole fraction.